Hello everyone. Today we shall see a topic from module 5 of embedded system. It includes the various mechanisms of inter-process communication. They are message queue, mailbox and pipe for today's session. So first of all, we'll see what is exactly a message queue. Message queue is an IPC mechanism which uses n byte of memory block as queue. Let me say once again, message queue is an inter-process communication mechanism which uses n byte of memory block as queue. So we'll see some of the features of message queue. Either one process or a set of tasks can use the queue. To write function, that is a write into the queue is using message post function, as well as writing into the queue is using message post friend function. So what exactly the difference between message post and message post friend? In message post friend function, posting a message of higher priority than the earlier posted message. Posting a message of higher priority than the earlier posted message. So that is the difference of message post friend function from message post function. The fourth feature of message queue is reading. A read from the queue is using message pen function. A read from the queue is using message pen function. Now we'll move on to the OS features which supports message queue. It has got 6 different features. The first one is each queue should be initialized before using the functions in the OS scheduler. Let me say once again, each queue should be initialized before using the functions by the scheduler. Second point, a write into the queue using the function post function. Write into the queue using the function post function that I have already mentioned in the previous slide. The third one, there is a provision for multiple queues for the multiple types or multiple destinations of messages. But each queue should have an ID. Next point is each queue has a user definable size or a fixed predefined size assigned by the scheduler. So each queue should have a user definable size or a fixed predefined size that is assigned by the scheduler or a scheduler. The fifth point is when an operating system call is to insert into the queue, the bytes are as per the pointed number of bytes. The sixth one, when queue becomes full, there should be error handling and user codes for blocking the task. That means when the queue is full, there is a necessary for error handling and user codes for blocking the task. So these are some of the main important OS features. Now we'll see. This figure shows the memory blocks at the operating system for inserting, deleting and other functions. So this figure shows the memory blocks at operating system for inserting, deleting and other function. So inserting is for task A, deleting function is used for task B, and the other control functions are event control block at OS. This figure shows a message block. So you can see in the message block, you can see it is similar as a memory. So it has got a queue top and a queue end. Queue top and queue end and pointer for pointing to the queue head and queue tail. And here they have shown 3 blocks. So that means 3 messages can be there in this queue. and pointers are also indicated in this diagram. Now we'll see OS functions. So this figure shows the functions for the queues in the operating system. Functions, different functions supported by the operating system. That we'll see in the next slide. So these are the OS function for servicing a queue. We have got 7 different OS functions for servicing the queue. That is OS queue create, OS queue post, OS queue pend, OS queue accept, OS queue flush, OS queue post friend, and OS queue query. So these are the operating system functions for servicing a message queue. Now we will see each functions in detail. OS queue, first one is OS queue create. So this function is used to create the queue and initialize the queue. So OS queue create function is used to create a queue and initialize the queue. Next one it is OS queue post. OS queue post. This function OS queue post is used to post a message to the message block. So OS queue post function is used to post a message or send a message to the message block. Next one it is OS queue pend. OS queue pend is used to wait for a queue message. This function is used to wait for a queue message and reads and deletes when received. OS queue accept. This function is used to delete the present queue head. After deletion, the queue head pointer increments. Let me say once again, OS queue accept. It is used to delete the present queue head. After the deletion, the queue head pointer increments. Next is OS queue flush. It is similar to flushing. So that means this function is used to delete the message from queue head to queue tail. OS queue flush is used to delete message from queue head to queue tail. That means completely flushing the message. Next is OS queue post friend. This function is used to send a message as per the queue friend pointer. It is similar to, this function is similar to OS queue post. As I mentioned in the second slide, here higher priority message can be serviced or can be posted. Now next is OS queue query. So it is similar to querying. So this function is used to query the message block. This function is used to query the message block. But the when it is read, the message is not deleted. This function returns pointer to the message queue head if there are the messages in the queues. If else or else, it will be pointing to null. Next we will see MailBox. So we will see the features of MailBox. So MailBox is an inter-process communication that can be used only by a single distinct task. The source is the task that sends the message pointer to a created mailbox. And the operating system provides a provision for inserting and deleting the message into the mailbox message pointer. So each mailbox needs initialization before using the function in the scheduler. And there should be a provision for multiple mailboxes for the multiple types or multiple destinations of messages. Each mailbox should have an ID. It is similar to message queue. And also it should have one message pointer only in which it can point to the message. So there are three different types of mailboxes. One is one message per mailbox. Second one, multiple unlimited message queuing up. Third type, multiple messages with a priority parameter for each message. Let me revise it once again. One message per mailbox, multiple unlimited message queuing up, multiple messages with a priority parameter for each message. So these are the three different types of mailboxes. Now we'll see the operating system function for mailbox. This is also somewhat similar to message queue. So here we have got 5 different operating system functions, that is mailbox create, mailbox write, mailbox wait, mailbox accept and mailbox query. In this first one, mailbox create. So this function initializes the mailbox contents with a null pointer. This function initializes the mailbox content with a null pointer. The second function is mailbox write. So that posts a message to the mailbox or sends a message to the mailbox. Third one, mailbox wait. Wait for a mailbox message which is read when received. Mbox wait is a function that wait for a mailbox message which is read when received. Mailbox accept. So that function reads a current message pointer after checking the presence yes or no and deletes a message when read and it is not needed later. Let me say once again, mailbox accept reads a current message pointer and deletes a mailbox when read and not needed later. The last one it is mailbox query. Queries a mailbox when read and not needed later. Now we will see the next other method of interprocess mechanism, that is pipe. So it is a mechanism used for interprocess communication and which this device is for inserting and deleting from that between two given interconnected tasks or two sets of tasks. So writing and reading from a pipe is just like a C command, fwrite and fread. So we can read and write from a pipe using a C command, fwrite and fread. So now we will see in detail how we can read and write using pipe. So there is a one task function, that is fwrite, can write to a pipe at the back pointer address. So we can use a task function, that is fwrite, to write into a pipe at the back pointer address. And another function, that is fread, can read from a pipe at the front pointer address. This is very important, writing from the back pointer address and reading from the front pointer address. And also it is very clear that in a pipe there may be no fixed number of bytes per message, but there is an end pointer. There is no fixed number of bytes per message, but there is an end pointer. Therefore, a pipe is limited, pipe size is limited and have a variable number of bytes per message between the initial and final pointers. And also pipe is unidirectional, that is one thread or a task insert into the pipe and the other one deletes from it. So this figure shows the write and read from the pipe using the device drivers. So we have got two tasks shown in this diagram, that is task A and task B. Task A is for writing and task B is for reading, and we have got pipe device driver for handling this by the operating system. So these are the different pipe functions, that is pipe device create, open, connect, write, read and close. Let me say once again, the operating system function for pipe it is pipe device write, pipe device create, open, connect, write, read and close. Now we'll see in detail of these functions. So before we'll see in detail about the functions, this is the functional diagram for the pipe. So here we can see the different functions: device create, open, write, read function, pipe connect and close. And this figure shows a pipe message in the message buffer. Oh, it is just a pipe message. So here in this figure you can see pipe open and pipe end. Pipe open is the top point and pipe end is the bottom end. And you can see pointers, the P front pointing to the P front and pointing to the back. So what exactly last written byte will be at the P back. Last written or last inserted byte at P back. And P front is what exactly? P front, awaiting byte, waiting for reading. The byte which is waiting for reading. That means this is just similar to first in, first out. Whatever will be stored first, that will be read first. Now we will see the operating system functions for pipe. So we have seen the different types of operating system functions, that is create, write, connect, so and so. So we will see that in detail. So pipe device create is used for creating a device. And another function open. This function for opening the device to enable its use from the beginning of its allocated buffer. So let me say once again, this function is for opening the device and use it from beginning of its allocated buffer. The third function it is connect. Connect function for connecting a thread or a task, that is inserting bytes into the pipe to the thread or deleting byte from the pipe. Fourth one it is writing. So write function is for inserting into the pipe from the bottom of the empty space, memory space in the buffer allotted to. So that means writing will be in writing function for inserting into the pipe, that is from the bottom of the empty space. And reading function is from deleting from the pipe. Reading function is for deleting from the pipe, that is from the bottom of the unread memory space. Last function is close. This function is for closing the device to enable its use from the beginning. The close function is for closing the device to enable its use from the beginning. So that's all regarding the three different mechanisms of inter-process communication, that is message queue, mailbox and finally pipe. In the next section we will see semaphore. Thank you.